Alright, this is going to be level 2 of objective 24. This is the skills portion of 24. So we're going to go through the basics of parabolas, which will be this page, and then we'll go through vertex form of a parabola as well as standard form of a parabola. Alright, let's get started. So for our basics of parabolas, we need to be able to identify a couple things. So our x-intercepts are going to be the places where our parabola will cross the x-axis. So it's going to cross in actually two places on this parabola. It's going to cross over here and over here. So you want to just make sure that you're writing those as ordered pairs. So we hit at -2 and 2. So that's actually going to be written as -2, 0 and 2, 0. So now we want to take a look at where our y-intercept is. So where does it cross our y-axis, that vertical axis? It's going to cross right down here. And that's actually going to be the point of 0, -4. Now, when we talk about the vertex of the parabola, it's always going to be either the highest point on your parabola or the lowest point. In this case, since our parabola opens up, it's going to be our lowest point. So it's going to be that little point right at the tip. So in this case, it's going to end up being 0, -4. So it is a coincidence that our vertex and our y-intercept are the same point. That is not always true. It just happens to be that our vertex lands on the y-axis, so it is our y-intercept. Okay, so our axis of symmetry is going to be a vertical line that you could draw down your parabola that would cut it in half. So therefore, it's saying an axis of symmetry, so it's a line where your parabola is symmetric. So if I wanted to take both halves of this parabola and fold them up, they would meet, they would match, like a butterfly. So in order to write this, you need to make sure that you are writing it as a line, because it is a line, the axis of symmetry. So since it's a vertical line, we know it's going to be an x equals, and in this case, it's going to be x equals 0. So it will not always be x equals 0, but it will always be x equals the x value of your vertex. Because so asking about is our vertex a max or a min? So saying look at your vertex, so our point that's down at the bottom. Then I want to know, is this a maximum point or is it a minimum point? Well, in our case, this point is the lowest possible point, so it must be the minimum value of our parabola. So this will always be true. If your parabola opens up, like the arrows are pointing up, it'll be a minimum. If it's pointing down, so if your parabola looks like this, sad parabola, that's going to be the highest point, so that would be a max. But ours is a min. For our intervals of increasing and decreasing, you want to make sure that you're reading this parabola graph the same way you would read any graph. So when we're talking about intervals of increasing and decreasing, as we know from previous objectives, that's going to be our x values. So you're only going to write down x values. And when we read our x values, we read from left to right, from smallest to greatest. So if I put my stylus on the screen, and I go ahead and follow it along the parabola from left to right, you're going to notice my pen's going down. It is decreasing. And decrease all the way up to that vertex. So that means that I could say that my decreasing interval starts at -infinity and goes all the way up to the x value of my vertex, which is 0. So then that also means that my increasing interval, I'm going to start where I left off at the vertex, and I'm going to keep going left across my screen, and I'm going to go all the way up to infinity. So that means my increasing interval is going to go from the x value of my vertex all the way up to infinity. So that is not a coincidence. Your vertex is the point where your parabola changes direction. So you will always be using that x value of your vertex for your intervals of increasing and decreasing. So if you notice, our vertex is very important because that x value of your vertex is going to be, well, the x value of your vertex. It's going to be x equals for your axis of symmetry, and it's going to be the point where your increasing and decreasing intervals split around. Alright, so let's move on to our first form, which is going to be vertex form. As you can see at the top of the page, this is going to be our vertex form of a quadratic. A quadratic is a parabola. So if you look at your form, just go ahead and check that out. There's a values, there's h's, there's k's, and those are all going to be important values. So just like we have y equals mx plus b, and the m is that important value of your slope, and that b is your y-intercept, we're also going to have important values in our vertex form of a quadratic. So naturally, I'm going to skip to the third line of our gray box, which says hk represents the coordinates of what? So naturally, it is called vertex form, so hk is actually going to be giving us the vertex. An important thing to note is if you look at your formula, it says negative h and then plus k, but your actual ordered pair says hk, meaning you're going to take the opposite of h and then keep k, and that'll be your ordered pair as your vertex. Hopefully that'll make a little more sense when we get down to number 4 and we try them out. But first I want to fill out that little gray box for you. So it says if a is greater than 0, parabola opens, and they're looking for up or down. So if a is greater than 0, that's just another way of saying if a is positive. So if your a value is positive, we know that our parabola is going to open up. And that would make, as I explained on the previous page, that would make our vertex a minimum. Because again, our parabola looks like this, something like this. So that lowest point would be a min. So if we want to go ahead and do the exact opposite of that, if we said that our parabola is going to, our a value will be negative, so then that means that our parabola will open down, which means our vertex will be a maximum. And again, if I make myself a little sketch, here's my parabola, it's opening down. My vertex is that point at the top, which is our maximum value. I'm going to skip over the parent function graph really quickly so that we can take a shot at knowing max or min for our vertex, as well as pulling out the vertex from looking at vertex form. Okay, so if we look at our first one, it's going to look like this. So we're saying our h and our k, so remember it's negative h and plus k, and our vertex is hk. So that means opposite of h, so we're going to take negative 4, and then keep our k value, so negative 5. So that will be our vertex of the first one. We want to know, is this a max or a min? So for max and min, all we care about is this a value. The value is out in front. So if you look back up at your formula, it says a is the number that's out in front of the parentheses. Our a value is negative 1, right? So if it's negative, it means our parabola opened down, which makes our vertex a maximum. So let's try that for the next two. So if we looked at this one, our vertex is going to be the opposite of what x says. So it's going to be positive 3, and then the same y, so negative 4. And we'll take a look at our a value. Our a value is a half, but we don't care if it's a fraction or not. That'll affect things later. What we do care about is positive or negative. It is a positive value, so parabola opens up, which makes our vertex a minimum. Let's try one more now that you're getting good at this. Okay, so vertex should be -1, 5. Our a value is a -2, which means parabola opens down. Our vertex is a maximum. Okay, so real quick, I'm going to go ahead and graph our parent function. So I'm going to jump back up. A parent function just means that nothing has been done to it. So in our case of parabolas, a parent function will always be centered at 0, 0, so our vertex will be 0, 0. And it means that it hasn't been like stretched and widened or like made skinny. It's going to be the original function of a parabola, which we saw a lot of parent functions when we went through Objective 23. Okay, so for the first one, all you're going to do is plug in each value to fill out your chart. So we're going to plug -2 in, so -2 squared is 4. And hopefully we can do these. We should get 1, 0, 1, 4. So it's just a matter of go ahead and plot your points. So once your points are plotted, go ahead and draw your parabola shape through it. So once you've drawn your parabola shape, make sure you are putting arrows on the ends of both sides of your parabola, because parabolas do go on forever. They do go on for infinity, just like a line. So make sure those arrows are on there to make it accurate. Okay, so on the next page, we're going to go ahead and go through a problem of if they just gave you the vertex form of a quadratic, could you find all the points you need to go ahead and graph it over a specific domain? So let's go ahead and try that. Okay, so let's go ahead and first write our vertex from our vertex form. So it's going to be opposite of h, same k. So we're going to do the opposite of h, so it's going to be +3, same k, so +8. We want to know, is this max or min? Well, let's look at our a value. It says it's -2. Negative parabola opens down, so that makes our vertex a maximum. So it's going to be a max. Our axis is symmetry. So if we remember from earlier, our axis of symmetry is always going to be x equals, because it's an equation of a vertical line, and it's going to be the x value of our vertex. So it's going to be x equals 3. Okay, so it gives you a little clue onto how to find your x and your y intercepts. So it says to find your x-intercepts, set the entire function equal to 0. To find your y, plug in 0 for x. So the reason for this is because if you thought about it, when you have an x-intercept, you have a number, comma, 0, right? And when you have a y-intercept, you have 0, comma, some kind of number. So if you think about it, if I'm looking for a y-intercept, I'm setting x equal to 0 because x is always 0 when you have a y-intercept. And then you're setting the entire function equal to 0 for an x-intercept because when you have an x-intercept, y is always 0. So our y value is 0, so therefore our f of x is 0 in function notation. Okay, so let's go ahead and give those a try. For these, I'm going to set them up for you, and you should know how to solve these. So first, let's set up our x values to find our x-intercepts. So that means we take our entire function. So wherever I see an f of x, I'm going to put a 0. I'm going to set that equal to our equation, which is -2x minus 3 squared plus 8. So go ahead and solve that to find our x-intercepts. Okay, so when I solved that, I got 5 and 1, and hopefully you did too. So you just need to make sure you're writing them as ordered pairs. So I need to make sure I'm writing 5, 0, and 1, 0, because those are x-intercepts. Okay, let's go ahead and set up our next one, which is going to be our y-intercept. So again, y-intercept says plug in 0 for x. So that means we have our f of x, which is really our